All right. Yeah, welcome everyone. I'm Ben Daan from the Netherlands calling. We're here to talk about WrongSecrets, of course. First, a short introduction about me. I'm a security engineer / consultant freelancing currently, and I have been in security for about 7 years now, I think, mostly in companies doing something with software development. And secrets management is one of the pet peeves, I would say, on which I joined forces with Jeroen, who actually sort of dragged me into the project. Bring it over.
All right, so Jeroen here. Thank you very much for the awesome introduction, Tanya and Ben. I'm a principal security architect at a large company, which sometimes bores me to crap. So in terms of not being able to code anything, not able to go into deep tech, and with OWASP WrongSecrets, I'm able to actually do that a little bit differently and start working on that. I've been in security for a long time. Also worked on some other OWASP projects. Yeah, and if you basically just enjoying the ride with this. Just to repeat ourselves on, if you have any questions, feel free to just use the chat. I'll be monitoring that during this presentation. I'll try to answer anything possibly within this 2-hour time slot. All right, let's go. So we have a few boring slides and then we can start demoing. Let's start with the most boring stuff, which is of course the most important question. What are we doing here? What's a OWASP WrongSecret? So OWASP WrongSecret is a vulnerable app, which you'll see in a moment, not like the typical vulnerable app like Juice Shop or Webcode, where you can hack all the things, but it's specifically vulnerable that it leaks its secrets in one way or another by using misconfigurations, basically. It's also a secret detector testbed because you can now use this WrongSecrets project and then just use your secret detection tools like GetSecrets or TruffleHawk or all the others and see like, hey, by the default configuration, can it detect all the secrets that are hidden in the repository's code and their configuration and stuff? By now we can tell they don't, but they do see a lot of things, and we'll hit some of that during this demonstration. Basically, there's a few goals. The first one is basically we want to educate people on secrets management and its pitfalls, because secret management is often harder than you think it is, because you start out with a beautiful program, you start out with lots of beautiful infosec activities or cybersec activities and all the other jazz. So, but then eventually you need to start protecting your actual golden things or your diamonds, basically, and that's where stuff gets a bit rough, because how do you do it properly? How do you maintain that? And of course, you can always tell from a abstract perspective what that should be and what are the best attributes from a policy perspective. But when it boils down to doing this properly, it's easy to make mistakes. So that's why we make these mistakes for you. These are not self-made up mistakes. As you can tell by now, we've been long enough in InfoSec to see a lot of different mistakes in the wild, and we replicate those within the application. So nothing you see here is far-fetched. It all happened, and all the issues you'll see later on in the GitHub page of new mistakes to be implemented are actually mistakes we found in the wild. Well, because we've both been a consultant for quite a long time. And well, you see lots of different companies, you see lots of different people trying hard to manage their secrets, and we see lots of beautiful mistakes, and we hope to make you enjoy those mistakes with us. And while you see our mistakes, and you'll see that during our presentation of these exercises, we hope it can help you to reflect on your own secrets management, as in, hey, did we make the same mistake? Are we actually checking our engineers, or am I checking my own code not to do this? Or, hey, we will end up with this mistake if we continue like this. What can we do to prevent that? And we hope that with all of this, we can promote secrets management as an important part of security. So our project started to exist in October 2021, when we wanted to give some presentation on how to automate secrets creation and embedding using HashiCorp Vault and your CI/CD setup. And a little later, we started actually working on that on an actual OWASP project basis. And we started creating basically the project somewhere in October 2022. So we're live with the actual project for a year now, trying to make this better. And if you have any feedback for us on this project so we can further improve it, we'd love to take that in with us. Over to you, Ben.
All right, just before we get started as well, first a word on what the app sort of looks like. So we intend to have challenges at every layer. And some of these mistakes Jeroen was referring to are mistakes that we made ourselves, right? So that's not necessarily something that customers where we were did. It's oops, it turns out this wasn't the best way to do it. And that's sort of how you get started and learn. Thus, we want to just incorporate as many facets of this as possible. So our app is built on Java Spring Boot. And then there are challenges related to the application code, to the configuration, related to the container that we're building it in. And then depending on where you run WrongSecrets, you can also use it in Kubernetes, not just in Docker or plain Spring Boot. And then you'll have HashiCorp Vault potentially as well, where there is some configuration mistake in there or at Kubernetes level. And finally, we also integrate with the different cloud providers. So we have a setup both for AWS, GCP, and Azure. So if you want to run it there, there are at least 3 cloud-specific challenges in there. And they really relate to the specific services of each of these clouds and how you could potentially make a mistake in setting one of those up. And then there were some more lightweight ways to deploy Kubernetes as well, with support for Minikube and Octado. And one thing I do want to say is it's us presenting right now, but we have a whole lot of contributors and testers and people who just help out on a regular basis. We're volunteering in this project, and I just want to give a shout out to everyone helping us on a regular basis. And you can become one of those too. It's really, you can just reach us on the OWASP Slack. The OWASP Slack is open and available. So go ahead, shout out, give us a message, file a GitHub issue if you have a great idea. And make a pull request even. You're welcome to try and start. We'll help you get started with the project as well. See you get set up and help you maybe implement this if you've never contributed to open source. Then we have some pointers for you on how to get started as well. So we want to make it easy for you to get started with this and start learning. And if you're up for it, start contributing. And just writing documentation is also fine. And also, we have some sponsors that we also want to give a short shout out to. So there's GitGuardian, JetBrains, Docker, 1Password, and AWS, who on various levels help us do some things like integrating with some of their services that normally we wouldn't be able to do. But they were kind enough for us to let them use some of their services for free, for example. So as volunteers, we could use this as well. Finally, we can really use your help, like I said before. Here's the GitHub link as well, github.com, OWASP WrongSecrets. That's where we host that. It will really help us if you give us a star if you like the project, or share it on social media. But most importantly, just take the project for a spin. If after this demo you're convinced that maybe you can learn something about this, or you or your company, then try and spin it up and give us feedback. File an issue if you run into anything. If something's not clear or something's not working for you, or you think the explanation can be improved, reach out to us. And really, we want to promote helping us and just helping the community with that. It's not just us, right? Like I said, this is for teaching people how to do secrets management. That's what we're about. With that said, let's get down to hacking. Jeroen, are you all ready and set?
Yes, sir. If I can take over the screen, let's get started.
Sure.
So here we are. For those who want to do this live with us, go over here to Wrong Secrets commune. I'll actually share this in our Zoom chat because I think doing this interactively would be funnier. Let's get started. So our when the architecture was discussed, of course, this is mostly how we just to make sure. Can you see my screen over here?
Yes, I can see your screen. It looks good. You might want to make it slightly bigger if that's possible.
It is, luckily it is. So this is us running in cloud.octito.net. We have a special thing that Ben will demonstrate later. We're in AWS, but like Ben earlier explained in the architecture level, there's multiple different ways how you can run Wrong Secrets. And what's always available to you is running this directly in Octito or on what's it called again?
Heroku.
Heroku, thank you. Which you can always use. But as you can see over here for Heroku, which is just a Docker container running live on the Heroku infrastructure, you won't have any access to Kubernetes. And whereas with Octito, you do, because that's where we actually have a Kubernetes setup running. All right, having said all that, let's get started. So as you can tell by now, we have a bunch of secrets, like Ben already said, and here you can find the index of all the different secrets out there with a focus on something. So whether that's Git or Docker or Kubernetes config or logging, or it's on the front end or other things, and that's varied all over the place, basically. We also tell you whether you can run the secret or not, which technology you need to use. And we'll start out with a few simple challenges that run inside a Docker container. And after that, we'll actually do some cloud stuff, which Ben will show. And after that, just if we have time left, we could answer any of your questions or just dive into any of the challenges, because we're all about to see that the app will actually help us to solve the challenges so we can do it together. So let's start very simple. Challenge 0. The challenge 0, you can see if you understand how it works. The opening challenge, of course, feel free to ask in the chat. Thank you, Tanya. So the opening challenge is simple. Basically, we need to know if you're able to use the form, or you need to be able to know if you use the form. And the correct answer is the first answer. You can copy paste that in, you submit, and you actually got your first point. How beautiful. What you normally see when this is not running in capture the flag mode, because you can also use this with Wrong Secret CTF party or just with Wrong Secret CTF. If you go to Wrong Secret -CTF, etc., you'll get a CTF instance where you can do capture the flag games with as a team. We support CTFD and Facebook CTF and a few others, so you can actually have an actual competition. Then some of this stuff is disabled, but currently in the normal running mode, for every challenge, you'll have the show hint button that will tell you like, hey, for this challenge, you can solve it by using the following steps, and a lessons learned button, like what's wrong with what's happening over here, and how could we have prevented this from happening? So far, so good. Any questions about the basics of every challenge?
I like that you get a point for logging in. So no one comes away with 0 points.
It's funny because if we have time, we hope we can elaborate on some of the challenges, because some of these challenges were actually introduced by friends of ours that said like, hey, I'm no tech guy. I'm a driving instructor, but this sounds like you have a wrong password manager. Is that the same thing? And then funny enough, later on, other people who took the challenge, like administrative folks in a CTF party within a company, were actually also able to solve these sort of challenges as well, because they understood the exact pain that this driving instructor has gone through, or actually the big ass laugh he had about his colleagues just using the silliest password on his password manager. All right, let's go. So let's start as simple as possible from our application perspective. So the first challenge I want to talk about is the centralized hard-coded password. Oof, that's already a big thing because now we can dive in a little bit into the code. Basically, when people write a proof of concept, they often start with a hard-coded secret. That might sound silly, but I do the same thing. If I need some product typical code because I have no clue whether the API is working, then sometimes we just put the password somewhere and just go on. Because we're so focused on, at least I'm then so focused on getting the API to work that I have that hard-coded password. And you're always just one step away from forgetting not to commit that to Git. It's that simple. So can you spot the secret when we're looking into the code? And now the interesting part happens, because I think this is a great time to talk about our project structure a bit. So this is our project loaded in IntelliJ. I'm not sure if I think there should be a way to actually zoom in, right? Is there a way how I can?
Probably. You could also, I mean, if you're on a Mac, you could press the command button and then ++++, and that will zoom in.
Oh, wait a minute. Maybe I can do. Sorry for this, guys and girls.
It's okay.
Dems. Let's do this a little bit differently. I can just share this one. Now you should see just my IntelliJ, right? Is that correct?
Not yet.
No, not yet. Let's try that again. How about now?
In the meantime, we have our first PR. Small grammar mistake. Thanks a lot.
It
nice.
changed.
Thank you. Ooh, grammar mistakes.
IntelliJ now.
Nice. Okay, now let's see if I can. All right. Well,
probably
let's see.
View.
Yeah,
probably view. There's a zoom or something.
Appearance, and then let's see what happens with presentation mode. How bad can it be, right? Oh, now I can't see squat anymore. Sorry. View, appearance, exit, presentation mode. There used to be a zoom thing in there, but
I usually just zoom on my computer and I'm like, hey, be bigger now.
Apologies for the rough and tumble there.
It's okay, it happens to everyone.
So let's go over. Oh yeah, maybe I know a little bit of a silly trick if I just use a smaller screen view. It used to be the case that there was a zoom over here directly, but
is it in window maybe?
Oh yes, that could very well be.
Zoom, second from the top.
Oh,
second. Yay! No, it's okay. So I guess we just have to press zoom a bunch of times. That's not zooming.
Not zooming at all. Anyway, okay, maybe we should follow a bug. I'm not sure. By the way, we are sponsored. We are gracefully sponsored by them to actually have IntelliJ from them as in the ultimate edition, so we can speed up our development in that sense. Nice. So I'm very happy with the tool. But let's just try to see if you can you somewhat see what I have here on my screen, just to make sure.
I can. It's a bit small for me, but I'm also on like a tiny laptop screen compared to my normal giant screen. Everyone that's viewing, that's not me. How's it? Yeah, everyone. Okay, so someone else says they can see well, so then that's good.
Okay, thank you, Shlomo, for responding. All right, let's just continue. All right, thanks, Jeff. So how we structure the application over here, we basically have, so it's a typical Maven Java application. Why? Because it's a structured language, easy to develop on, easy to learn the fair basics, and to be able to contribute and just follow the lines of everything else. So we got a bunch of tests. We got here the main folder with the Java and the resources. Then next to that, we have a bunch of Docker files for different features, like to Dockerize WrongSecrets itself. We also have a web desktop, which will just launch you a webtop preloaded with all this good stuff you need to do the exercises. This can help you if you're doing this on a corporate computer. You're not allowed to install tools that we recommend to use. Then all these tools are pre-filed in this web desktop, which you can just run on your system if you have Docker or Podman or something like that. Then next to that is the Kubernetes definitions. So we'll talk about that a little bit later. And then we have Azure, GCP, and AWS over here, which contain our infrastructure as code, where Ben will show you a beautiful tour with, at least for the AWS part. And we can hang out in the AWS cloud. So that's about the structure of our project. And of course, we have Octito, where you possibly might be playing on right now. So the question was, let's just go back, is that there's a hard-coded secret such as the password in code. Now, there's a bunch of things we can do, right? We can, of course, ask how to solve this. And we'll explain you there that you can use Git secrets to easily detect it. And then you'll find it. You can also, when you only have a jar file, just use JetX GUI or JDGUI to just check in the jar file and search for it. And we can also use this, like grep, and just try to grep for the password, and you'll find it, which is for sure. But I'll always love to misuse this challenge and get you a little bit through our code. So this is the first challenge. And it was a Docker-based challenge. So here we have our challenge 1 class. And you'll see a bunch of things that are not that important, to be honest, for now. But what we're looking for is the password. And it's a constant. That's annoying. If we now go over there, we'll follow it. And we got this, the full login password, do not change, exclamation mark. Huh. How hard can it be, right? Would this be the one? Just to make sure. Are we cheating? As in, would it accept any answer? Nah, it doesn't. Well, that's good. But would this then be the default password? It is. Awesome. Okay, so what can we learn from this is that once you have access to the code, it's that simple. Any hard-coded password directly in code, you can easily find. And if you want to take the challenge up a notch, just create a jar file, follow the README instructions, and then try to find it using JetX GUI or JDGUI, and it will be fairly easy. If you feel now by now, I'll do better, we just compile it to native stuff or whatever, you know, so we have C++ or whatever. We have a bunch of reverse engineering challenges that we might touch upon if we have time during this session. And then you'll find out that ain't safe either. But so for now, code is a problem, right? Okay, so code is a problem. Let's not do code anymore, right? Let's not hard code anymore in there. So the very next challenge could, for instance, be, let's just put it into the Docker file, right? Because what if we no longer put it, I think by now you're going to get this, right? If you no longer are going to put it in code, maybe we can just put it in some environment thing that's loaded up in there like Docker. Just to make sure, don't feel bad if that's the case. Can you raise your hand if you do not know anything about Docker containers? Don't worry, there's plenty of them. If that's the case, we can do a short streak through Docker. But if I don't see any raised hands, which I don't right now, I'll continue. No raised hands, I'll continue. Of course, you can put stuff in your Docker env file, right? So you can use Docker env to set a password. And that's a great idea to share with everyone. You can easily spot the secret now by looking at the layers we're constructing with a tool like Docker. So we can just follow the hints over here. And we know that we're on version 1.6.2 RC1. That's just a version we made specifically for this presentation. So we have the latest and greatest features in there that we'll soon release because we figured that would be fun. So here the fun starts of having a terminal. This is zoomable. That should be easily. So I'm in the root of the WrongSecrets folder. So what I need to do is right now just follow these commands, Docker history trunk, and then the tag name, where the tag name will be something along the lines of 1.6.2 RC1. And then there's no vault because this is just a Docker. Oh yeah, let's do this differently. Docker, or we can just do Docker pool. Of course, it's a bad idea in general, but for this it works. We can just pull the latest Docker image. And when we wait, it's my Docker running. This is a, let's see if we actually have that over here. Apologies, it's the demo Lord turned with me today. Okay. Ah, yeah, that's the one. So that will be Docker pull WrongSecrets latest no vault. So it's just going to pull the latest, which is the one that we're currently using. Feel free to tag along on your own computer if you have Docker. You can do the same for Podman, of course. And we also have tests for, I think it's called Colima, where we also made sure you can use that Docker runtime. So now we can nicely ask Docker, like, what's going on in this thing? So we can just say latest no vault, where we'll see all the layers being composed, hardly readable that way, of course, because of the zooming. So if we now ask it nicely this, just grab Docker env password, we should see something, right? And here we see env Docker env password, this is it. Okay, might that be the password? Yes, hopefully. Yes, luckily, that was a little bit of a delay. So with this, you can see like, okay, hiding something in Docker is not a good idea either. Funny backstory of this one is we started creating this application also to, as a little bit of my own personal atonement, because when I started in security and we didn't have for a given company a nice secret storage management solution, a dev came to me and said like, where do I put my private key? And I'm like, do we have any of these secret management facilities? No, we don't. Well, then you just put it in your Docker file for now. And ever since then, I felt guilty about not being very helpful in that direction. So don't worry. If it happens to me, it can happen to all of, well, obviously it can happen to all of us. So it also happened to me to do this wrongly. So that's a Docker challenge.
Maybe nice if you also go the Docker Hub route to see just how public this is.
Oh, yeah. Yeah, that's actually a great idea. So we have Docker Hub, right? I think that's where you can find our images and also the other images. And so here's our WrongSecret image. And the one we were using was the 162 RC1 latest, but it's actually the same as latest no vault. Here it is, and the no vault will be the same, but this is the image we just used. It's very fresh, as you can see. And now over here, you'll see actually everything that happens to create the Docker image. And there you'll see the same thing, right? The Docker env password. So it's just public. There have been a lot of publications lately on this being a problem, because there are still plenty of images that actually have secrets set up in their Docker image. Of course, this is how you do it if you don't have the Docker file itself. Obviously, you could have, in this case, have a look at our beautiful Docker file where we actually have hard-coded it for you. But in many cases, you can just use the Docker Hub or something else. So that's Docker. We could also spend some time on Kubernetes, but I think this is a beautiful moment to hand over the steering wheel back to you, Ben, so we can talk a little bit about our cloud infrastructure.
All right. Let me bring up the repository again. So if you want to spin up WrongSecrets in any of the clouds, and let me zoom in just a little bit. Here, the command plus works nicely. This is not IntelliJ, sorry. But let's go to, for instance, GCP. You could go there and change directory to maybe zoom in there a little bit as well. Is this readable? Let's go there. Okay, so you could go to GCP, and here there's some Terraform already provided for you. And it has some defaults like, for instance, which region that you deploy it in that you might want to change. This is Azure, actually, I see. Anyhow, we have this for AWS, Azure, and GCP. And then in each of these folders, there is a README as well. So to set this up, you can just follow along in this README. It lists which tools you need to have installed. It says what you need to do as a sort of prerequisite, especially if you want to share this with multiple users and not just for deploying this yourself. There is some infrastructure that you might want to share. So normally Terraform, there's the state file, for example. And of course, we have a hidden secret in the state file. But if you're working with this, collaborating on multiple people, then you want to share this state file through each of the respective clouds. So setting this up either via an Azure storage blob or a GCP bucket, I believe it's also called, or an AWS bucket. That's all possible and is in this README right here. And then it'll guide you through the steps with which commands to run. And if you're familiar with Terraform, you'll probably find this all relatively straightforward. And then we have finally a bash script to finish off any of the existing installations, like the actually applying the Kubernetes pods, etc. You can do this all manually, of course, but we decided it's probably a bit of a nicer development experience, especially for the ones who are not using this daily, that they can just kick off this script. And if they want to even front it with like a load balancer, etc., etc., and you don't have to figure that all out yourself if you want to do this in a somewhat different way. But normally speaking, it's just deployed for you, and it's a piece of vulnerable or semi-vulnerable infrastructure. So best not to run this on your own production clouds, and instead try this in a somewhat isolated environment. So having deployed this, I think it's maybe nice to demo some of the challenges that we haven't demoed anywhere else before. And one of those is the privilege escalation one. So if we take a quick look at challenge number 11, which is again specific for the clouds, we have, and this one actually changes, depends on which cloud you're in. So currently it's IAM privilege escalation with SSM parameter store, but obviously that's not available in GCP. So in there it would be something else, and in Azure it's a key vault related challenge, for example. So what's happening here? The first two cloud challenges are about Secrets Manager, AWS Secrets Manager in this case. And one was where something's hidden in the state, and the other one is mounting something via a nice Kubernetes controller. And it's iteratively, it gets better with these challenges. But yeah, just there might be some configuration problems in the road, and especially AWS IAM is one of those beasts that tends to become really complicated. And this challenge is made to show that off. So there is an IAM problem right here. And now, of course, we could start with the admin role that we all deployed this with, but that wouldn't be really fair. We could just list out the secret. That's no fun. So instead, we have provided a role for you, which is the role can't read secrets. And the task is to see and try and get to some of the different paths and see if this can maybe reach anything else. And there's several ways to go about this. So if you're not very familiar with the AWS command line or the AWS implementation details, then it might be very helpful to run a tool like Scout Suite or Prowler, and they will help you look at the misconfigurations that you have in the cloud. So I've done a bit of a Scout Suite report here from my admin role, that is not from the Can't Read Secrets. I will jump into that in a bit. But this will give me just a bit of an overview of what's there. Now, there are some problems I see already, but the one that we're concerned with right now is in IAM. And here there's a few things. going on. But what we most likely want to see is have a look at the roles that are configured. So what is it that this application deploys? Let's just first get a bit of a feel for what there is. And now you could either do this by browsing the application code, of course, but this might be a bit more intuitive for you. And we see there's some Terraform auto-generated role. There's an AWS service role for support, service role for Amazon EKS, WrongSecrets secrets manager. That sounds interesting. Let's look at that later, maybe. Bottle Rocket, EKS CTL, service role, an administrator, the can't read secrets role. And then we could also look at what rights this role has. So that would probably be one of the first ways to start, right? I have the can't read secrets role. What could this role actually do? So one way is to go to the CLI and try and enumerate all of the access that you have. But yeah, that's not necessarily the nicest way to do this directly. So instead, we can go to the policy and look at what rights this has. So if we look at this one, we see that there is a statement right here where essentially it says it denies secrets manager and SSM. So can't read secrets. But what it does allow is assuming roles, listing things in IAM, getting things from IAM, describing things there. So particularly this assuming roles thing is an issue. So often setups in AWS, you would assume a role and then you would do something with that role. And if you're not careful, you end up with STS assume role rights that are all over the place. And then very complicated things can happen where you can jump from one role to the next, to the next, to the next, and suddenly you're admin. A bit like you would back in the day, like in Azure or in a Microsoft AD environment, just hunting for the trail to global admin, right? And this is the AWS version of that, essentially. So this Scout Suite in here is a useful tool to help us to, just get a quick overview of what this role can do. Now, we have this can't read secrets role, and we know that. And then we had this WrongSecrets secret manager away up here before. And what's important in AWS, on one side, you have the rights that AWS you're granted to within your role, but on the other hand, you also have the role trust policy. So essentially that says which entities can assume this role. And in here we see two statements. One is that it allows OpenID Connect, and this is a bit small, I fathom, but this is essentially the statement that allows our EKS pod to connect to AWS and use this role and read secrets so that the app actually works. But in addition, we see this statement right here. And this says, essentially, if you have IAM access, then yes, you can assume this role. Now, we know from the other role that indeed we do have IAM access to that role. So we could potentially try and get to the secret by jumping from the can't read secrets role to the WrongSecrets secret manager role. The next step is then, of course, how do we do that and how do we actually get this secret out? So let me go there. And one of the first steps you would do is configuring your AWS profile. And that would look something like this. Maybe zoom in just a little bit again. This all right? I hope.
It's a tiny bit. Oh, it's small now.
Yeah.
Wait, go back. Oh, that's better.
That's better. Okay. All right. So the AWS profile is in .aws/config, and then there would be all the way at the end, I have the WrongSecrets admin, and that's my sort of the role that I deployed all this with, which allows me to access. For the CDF setup, we have a slightly different way of doing this so that also non-admins are able to assume this role. But for now, this is the first role that I have. So OWASP WS can't read secrets. And that would then allow me to list out the roles. So list roles, just to verify, file OWASP WrongSecrets can't read secrets. Whoops, typo there probably. I guess list roles. Sorry, IAM. There we go. And immediately we see indeed, yes, we have access and we can list out these roles. So here's this WrongSecrets secrets manager role. Now, the next thing to set up right now would be to add that in the profile again. So jumping back here, and I already have it pre-configured just so I don't have to type all that out, where we say, okay, this source profile is now can't read secrets. And from there, we jump to the secret manager role. So close that off. And then what we can do is potentially do AWS secrets manager list secrets minus profile. I could set this as an environment variable, of course, but just jumping around now a bit. And I also need to specify the region. I believe we're in EU Central 1. It could be EU West 1, by the way. Yeah, it's West. Yeah, there we go. So now we have our secrets, but they're actually not in Secrets Manager. They're in Parameter Store. Oops. So what instead we want to do is AWS SSM describe parameters. Region EU West 1 again, and then the profile, OWASP, jackpots, it was. And now we see this WrongSecret value parameter, which is of type secure string. So now the next step, obviously, is to just get this parameter, get parameter, add in the name, and we get this base64 thing. Now we could try and go ahead and submit this. Let's see where we get. Huh, that does not seem right. Oops, okay. So peculiar thing about it is I said it before, right? This looks a base64 encoded, so potentially this is something different. What we could try and do first, of course, is to just echo this out and run it through. Whoops, that's a bit much. And base64 decoded, and then it looks all garbled. So one peculiar thing about this is, or well, peculiar, actually a good thing, the secure string property automatically encrypts it with KMS. And that would require a slightly different call, and it's way more trivial than you would think maybe it would be. You could just pass the flag in with decryption. And there we go. Now we have something slightly more readable. And see if that works. Your answer is correct. There we go. So that's probably one of the harder challenges in here, specifically if you're not familiar with any of the public clouds. This could be a nice one to sort of showcase what could happen if you have your the STS assume role or an IAM misconfiguration. And even if you have the parts correct where you don't put it in the code and you have it nicely in Secret Manager or SSM, and you use this, then this is one of the things that you need to look out for, essentially. But increasingly, these challenges do get up to a bit more best practices. So this challenge it's dynamically generated again. There's no way for me to jump into the code and figure out exactly what this value is. There's no artifact where it's published where we use this thing, and in the application, it's only sort of present in memory. Now, if you're in memory, then it's already mostly game over on very many levels already. So that's probably the attack surface, or the part of the threat model that you have to look a little bit less at, or be a bit less concerned about initially, at least, and first get all the other things right. But yeah, that's sort of the path to challenge 11. Now, if I'm correct, Jeroen, you want to go back to, let's see, challenge 15, was it?
Yes, sir. Yeah, before we jump there, this was a pretty dense, awesome one-on-one on IAM for AWS. Any questions about this before we move ahead? Don't worry, there are no dumbass questions about this at all, because IAM is just complicated.
It looks like we're good in the chat. Maybe you just did such an amazing job of explaining it. No one needs any. I thought it was good. Anyway, please continue.
Thanks.
Awesome. Yeah, well, awesome, Ben. Can I take over your screen?
Go ahead.
Here we are. Let's go. Let's move that away a bit. Okay. Let's see. So this is all about getting access, right? When you already have access. But let's try to make these challenges come together, right? So how about we check out the mistake we would have made in challenge number 2 or challenge number 1, where we hard coded something somewhere, and now see if we can actually get something like AWS access key from our Git history to access our system. And in this challenge, this becomes very interesting. So we could, for instance, still make the mistake of the prototype, right? We wanted to talk to AWS, so we just have some access keys hard-coded and committed and pushed, and we published it. So somebody out there will have a copy of our Git repository, and based on that, we'll be able to, in the Git history, find the AWS keys and start playing around with that. However, the AWS keys that we hide over here are no normal keys, and we'll see in a moment what's not so normal about them. So yeah, like explained, this is explained by a challenge, right? So we kept some AWS keys right in Git. This is a mistake. By now we got 3 credentials in there because different environments have different keys in Git, and there's a good reason for that, and you'll see later on why. And of course, the easiest it will be that I could show, hey, how can we do this automatically? But what I always like to do is just get us through. See if we can find this in any sort of way. So I checked out the repository. Let me create another tab. Just go to, we're already out there. So I'm in the root of my secrets, basically. And now what I have to do, let's see if we can get it both together on the screen. So you have to install Trufflehawk. I already did that. And now we can just simply ask Trufflehawk 3, hey, can you, for me, do some secret scanning in there, maybe? So let's do that, right? So Trufflehawk 3 is another iteration of Trufflehawk with some updated stuff in Python and stuff like that. You can also use the original Trufflehawk, but this just has a nice way of returning the results for this presentation. And then now it's scanning the Git history. So it checks out, as you can see it over here, right? We have some Git running, and Trufflehawk goes over there and just clones it locally, scans everything, and we'll come back with secrets. let's take this one out over here. Put this back in just in case something goes wrong. Because the secret we'll be having over is not on our local system, of course. It's only in our Git history. Let's see if I've pulled it anywhere else. Oh, it keeps on loading. For some reason, it's really slow right now. Apologies for that. Ah, there we are. So these are tons of secrets that it found. Note that these aren't all secrets, because some of it is just some string or some data that has a high entropy to it. Hence, Trufflelog things like this could potentially be a secret. So what we're looking for specifically was AWS keys, remember? So let's just search through our input. There's a bunch of them over here. So let's just, so here's an AWS access key. Maybe it's easier to search for those. So we just do AWS access key ID. So we just pull down the ones that we need. And then over here, we finally start finding one that actually also has a secret access key attached to it. It could be this one or another one, but by now you can see we have all three of them, right? So if we would use this one, see if this is, no, that's not the matching key. Let's just try the next one. Is this the matching key? That's not the matching key either. Then this should definitely be it. And otherwise they have the demo lords against us. And then I apologize. Ooh, there's something wrong. Oh, there is another one. Sorry. That's awfully strange. Let me quickly do some checks. So there is a way to actually, oh yeah, of course, I'm in the wrong environment. This is the right environment, the Octito one. That's where I will demo it from. Apologies, ladies and gentlemen. So doing the same thing, of course. Let's put them back in. Nope. Then I have to put the other ones in.
We have a comment in the chat that it's the same ones repeated. I don't know if that's helpful.
Ah, yeah, it possibly is. This is the right one.
Okay.
So this is the right one.
Thank you, Shlomo.
Thank you, Shlomo. Thank you so much. So this is the right one. Now, if this is the right one that's configured over here, how can we use that? The hint is they're not normal access keys. They're canary tokens. So what does that mean? Let's just try to use the credentials that we found, right? So those are, is this combination. So I would open up a new tab and just set them as my access keys. So that you could do. I think this is the right one. Let's just double check. Yeah, that's the right one. Of course, I can copy paste everything in, but we sort of. And here's the other one. As you can tell right here, right? This is the secret access key. So just run that. And now what we can do is we can run AWS STS get caller identity. With that, you can just basically check, are these keys working? And am I anything? And can I actually use STS? Here we go. Of course, I could also do AWS S3 list or LS, and see if I can find some stuff. And of course, we can do that for fun shits and giggle as well. So that will be S3 LS, I believe. Not sure if I need to give extra parameters. Access denied. So, but hey, the keys do something, just not allow us to do this. But what actually happened is something completely different, because here you can tell user/canarytokens.com. That's interesting. So what happened under the hood is that these access keys were used at an AWS account from canarytokens.com, for the specific key, I configured a callback. And that callback is actually configured over here at this domain, WrongSecrets commune cloud.tito.net. And what we'll see over here is in the stats, then I was using it. So here you can see it's been called with the AWS CLI, what you just saw me use that. And I just tried to do, my last command indeed was S3LS. So with this, if you have this running on your own system, you can do something very interesting, right? You could hide canary token somewhere by a misconfiguration and just see who calls it. And if it's called out, you know that people are going over your code, they're going over something. And if you put the canary token somewhere where people shouldn't be by default, then now you know somebody tried to go there and found these keys and was trying to play around with them. So how does that work? So for that, we enabled the Swagger backend. Basically, what's happening is that we have a callback defined over here at the canaries controller, which is /canary/token callback and token callback debug. And that's basically being called with these different parts of the data, basically of what canary tokens wanted to share with us, which is when it happened, the URL where the token is managed by, the user agent which it was called, the refer, the location, the source IP, and some other stuff. That way, if you configure this yourself in your own internal centralized system, you could actually just monitor whenever this is being used. So that's about the canary tokens. If you have any other questions about how the application works, by the way, you can just, in the newer version that we're about to release, just indeed from when it's enabled, you can just use this Swagger UI to go over our APIs and see how it works and play around with that. So that's about the canary tokens.
There are no questions. We have
Awesome.
some new people just joined us since you were talking, but yeah. Thank
All
you.
right, welcome, Osama.
Yeah,
So
one thing I might want to add on the canary tokens is I like to set these as my default profile. So just in case, I often make the same mistake and message myself, but if anyone uses my default profile, then I know my PC is probably compromised.
Exactly. Awesome. Let's see. Now that we're in the start screen, a few things that are nice to know. You can easily use the application for educational purposes anywhere. Feel free to do so, where you can enable CTF mode or not. If you don't want people to go over the hints, you can disable the hints yourself. You can see in the README how to do that. That way, people have to figure out it yourself, or you can really take the steering wheel as an instructor to explain what to do and what not to do. Of course, given that we present the application, we give the steering wheel back to the app. And that way you can just enable anything you like over there. Another thing that's over here is that spoilers are enabled. If you look at the code, because by now you know that all misconfigurations are out there, and feel free to do so after the presentation. You should be able to easily find a way how you can find all the answers to the secrets without doing anything. But with the new version, we can disable the spoiler endpoint, so you no longer can misuse that. And don't worry, when we're running in CTF mode, then that spoiling function to get the answers for free is also disabled by default. You can't enable that then. But anyway, have a good catch at it if you're really lost in trying to find the secret in one of these configurations. All right. I think those are the main challenges we first wanted to present. We're an hour deep in our presentation. Is there any sort of topic you beautiful people want us to dive into in terms of the challenges? Or do you have any general questions or something else? What would you like to do with us?
That leaves it quite open. Does anyone want to ask some questions or set some direction? I think that they're used to, this is the presentation and you shall be quiet and listen now, and not all sorts of just options and openness. Oh, Shlomo says, how about the Vault integration?
Thank you. Thank you, Shlomo. I think that's a beautiful one. Ben, do you still have the initialization scripts ready, or shall I spin up a Minikube version locally so we can present it from the roots? What's easier? Do you still have the initialization script in your terminal output?
I believe it is somewhere, but I'm afraid it got lost in the shell history already.
All right, then let's do this together. So let's do the vault exercise. And are you trying to encourage use of a secrets manager or showing how it can still be insecure? Let's answer that one first, Shlomo. So the question from Shlomo is, are you trying to encourage use of a secrets manager or showing how it can be still be insecure? If we go back to, let me try to answer that from a bit of a neutral perspective. You can put secrets anywhere over here, right? And you can still make security mistakes. We believe that you can, if you have Airbag configured correctly, as you see in Kubernetes, that you can use Kubernetes to manage its secrets. We believe that if you carefully configure your cloud correctly, you could use AWS Secrets Manager or Azure Key Vault or anything. Just make sure you configured it correctly. It's also beautiful if you use stuff like HashiCorp Vault, or if you use stuff like Achilles and stuff like that, as long as you configure it correctly. We really, depending on whatever is running on top, don't really have preference on where you put your secrets. Well, as long as it's not in code, not hard-coded in configuration, but really in a designated solution for secrets management, as long as that designated solution is configured correctly. For instance, if we would do something like serverless, whether on Azure or on AWS, all of this stack, the containerization is not really relevant there, right? It's just your cloud's secret manager that you're going to use eventually, or some integration to your secret management solution through your cloud, basically. In both cases, you need to secure that integration in the proper way. So it's really about configuring that correctly. But in the meantime, let's do the Vault one. So for that, you can actually follow our README, and I'll show it just for reference. So if you go over here, you click GitHub, you'll directly go to our repository. While you're here, feel free to press the start button. Not trying to push you anything. Oh, actually I am, but not to worry. If we now go to the Minikube setup, Vault exercise of Minikube, which is right here, you can actually follow this rightly with us. This might take a little while, so bear with me. If you have all of that stuff installed, all you just have to do, and it's literally all you have to do, is just run the script from the root. What it will do, it will spin up Minikube with a right version of Kubernetes with some virtual CPUs and memory. Right now using Docker. And what we're going to do right now is we're going to leverage Minikube to basically create a Kubernetes infrastructure for us. And over there, we're going to deploy Consul for storage, and then Vault on top of that. And next to that, we're going to deploy our WrongSecrets project. And then the WrongSecrets project will authenticate, will use its service token to integrate with Vault. And then one of our challenges, the Vault challenge will basically be used to leverage the authentication from the Kubernetes pod to using its service token to Vault to actually get the secret. That sounds like we need to hunt for stuff within Kubernetes, but that sounds also awfully complex, right? Because most people can't hunt for those. But what just if, right? What if we set up Vault in a way that sort of is secure, but we're just making mistakes? And that's where this challenge is all about. Let's hope we actually get this up and running, because somehow combined with Zoom, this is getting a bit slow. Otherwise, we have to skip that. In the meantime, is there any other challenge we could start off that you guys and girls are curious about?
I want to say a message in the chat, because people who are watching this later can't read the chat. So Ben says, too long, didn't read summary. Yes, use a secret manager and make sure it's configured correctly, because it's not necessarily safe by default. And that's a really good point. I just wanted to add that in there.
While Consul is loading, let's do something else. Let's do the password manager challenge maybe, so we can show something else. So this is a funny challenge that literally came from my friend Case. My friend Case is a driving instructor, and he had the awesome fun where one of his colleagues actually was using a password manager with a very short password, something along the lines is in hello 123, because we're the Netherlands, it's a Dutch way of saying hi. So here's a password manager challenge. We set up a KeyPass file in Docker container where we put the secret credentials to Alibaba Cloud in. Well, we don't have an account in Alibaba Cloud, but we just figured that's the only cloud and Tencent Cloud that we're missing, hence the joke. How can we get there? Okay, let's make sure we get KeyPass installed. And then make sure we can actually copy the file. And what we actually can do is now just have a look over there. Check the code of challenge 14, which we can do at GitHub, right? So we can just go over here in challenge 14, and there we see a KeyPass path and a KeyPass password. Well, that sounds awfully funny. So let's have a look at the KeyPass password that could possibly be there. And the funny thing is, we can actually just even search in the repository to find that, right? So let's see what we can find back. Welcome 123. Okay, so we can copy it from the Docker container. There's already the whole setup. We'll get back to the full challenge in a moment. So now what we can do is just try to see if we can find the KeyPass file. Of course, we can copy paste it out from the container, or we can just find it over here. And there we'll see the, let's see where it's at. I think it's over here. Where's my KeyPass? Oh, sorry. So if you look for the KeyPass file, it should be over here. Let's quickly check. Sorry about that. Yeah, it should be in the resources, actually. Resources Alibaba credits. Oh, there it is. Sorry, I was overlooking it. So that's right. Here. No. Yeah, we hide it actually. So that will be in test resources Alibaba credits. Now, if we try to open that, then this shouldn't work. Let's open it over here. And now if we open this password, basically, then if you have KeyPass 6 installed, of course, we can also do the whole shenanigans of just copy pasting it in, and we just use the password, welcome 123. Hey, we see something. Let's see what we have over there. There's a password. Well, that's an awfully complicated password. It's pretty strong, right? Isn't it? Would that actually be the answer to our question? Let's see if we're in the right one. Here we are. So we submit it over there. Yes, it definitely is. So what we've learned from this is you can have all the password management you want to, but let's make sure your master password is still somewhat safe. And again, not stored anywhere else. Now we're ready for the full challenge because everything is spinned up. If you can look at my terminal over here. Oh, it's where is it? Sorry about that. It's over here, right?
I have so many windows open right now. I think you're doing great.
Hold on, let's just see. Here it is. So what we did over here, remember, we just launched that, and then the console got in, and then we get vault in, and then it forwarded it, and then we needed to auto unseal it. And for that, we actually had some weird ass token, and then it said like, yeah, you're doing great. Now we can, wait, what? You're now authenticated, obtaining the root token, and we got our root. For those who don't know what Vault does, Vault is an awesome secrets management solution. But if you want to start configuring it, you first need to unseal every instance of your Vault cluster, if you have a cluster, which we had over here, like 3 instances being unsealed. And then you get a root token to do all the initial configuration. That root token is amazingly powerful. You can do virtually everything with that. So if we either need to choose between hacking a Kubernetes cluster up to a level we're not supposed to because something airbag holds us back, should we be able to use the root token to just try something? That would be awfully funny, wouldn't it? So let's go back to the Vault challenge, which is challenge number 7. That's the wrong one. We actually have to go to localhost 8080 where we're running it right now in the Minikube. And now you can actually see that the Vault challenge is enabled. If we now go for show hints, then it says find the secret vault in Vault using the locked root token, because it was somewhere in our logging. This might sound silly, but what many people do is configure a secrets management solution to make sure that every action over there gets logged. So the security teams can watch those logs and act upon anything that's crazy, whether it's using a root token or whether it's some other high privilege access. In all these cases, you want to make sure you act upon those. Sounds perfectly legit, right? But what if you by mistake log that token as well? Well, that's what we did over here, of course. This is not the exact token, as you'll see, because this is our actual token. That's great. So how do we access Vault again? Wait a minute. There's a port forwarding on port 8200. So that will be a local host 8200. There's Vault. That's great. Can I sign in? Nah, doesn't seem to be the case. Now, if I copy paste my token in, can I now sign? Oh, I can now sign in. That's interesting. So here's my secret for the secret challenge. And there's a Vault password or password. I don't really care. I hope this is just the thing we're looking for. So let's try to paste that in. Let's see what it submitted. It's correct. So what did we learn from this? Having Vault is not a bad idea. Using the proper authentication method over Kubernetes is not a bad idea either. The problem we're facing here is that we just logged too much. Luckily, you can configure Vault in a way that it doesn't log these sort of things. It just logs the HMAC of that, or the HMAC SHA-256 actually, which will be very helpful. Because then there is no token that you can just copy paste from your internal logging system and sign in and get the secrets. Any other?
A lot of secret management tools, they won't give you the secret back. So I was like, oh, it's letting us see the secret. Usually it doesn't let you see it in plain text. Some like Key Vault, for instance, won't do that. Key Vault's like, no, mister, you can rotate if that's what you're up to.
By default, that's the case indeed. And if you would normally configure a user within Vault, not use the root token, which is the master administrative access, there to say, like the highest privileged access, you would by default not get any rights. In fact, you wouldn't be able to list the secret setup, so you wouldn't even see this. In fact, the whole thing would just blink not allowed. You have to specifically, normally when you configure Vault, you have specific access rights to actually get there. The funny thing is, we'll have the same problem with Azure. And that's why I won't spoil everything. But if you have an AWS account with some free credits in there, spin up our exercises over there and try challenge 9 and 10 and 11. And you'll see a similar problem that we showed in AWS is also possible, unfortunately, when it comes to reading secrets for Azure Key Vault.
Cool.
But it's a good one. It's a good, lovely bridge. That's very cool. So that's the Vault secret. Any other thing you would like to cover?
Well, maybe one thing from me, Jeroen, one note. So we have this challenge for Vault in here, and potentially there's a whole lot more room for challenges right here, like RBAC misconfigurations within Vault, etc. But we don't have those challenges just yet. So if you are, or you know anyone who can provide those challenges or wants to help us build those challenges, or maybe even bring in suggestions and have us implement them, that's also fine. Then go for it and please reach out.
Feel free to always file an issue here. Just press new issue or go over here and just then select challenge idea. But just do make sure you do always not do something you've never seen before, but something you actually saw once in your life. We already had crazy ideas of things that we're pretty sure that never happened, which were like made up puzzles. But stuff like people using the Vault Injector sidecar and or the Vault Agent Injector, and then in the template just hide the secret itself instead of a reference to the data because they couldn't get it to work. That's an actual challenge we're very loving to implement. But finding a Vault root token double encrypted, symmetric and asymmetrically somewhere in code to make this the most beautiful decryption puzzle there is, not sure if we'll implement that. But at least file it, then we can have a look at it, right? Just to sort of set expectations. Anything else?
I feel like everyone's quiet. Okay, yeah. So were you able to cover all this? This was a lot of content. This was really good. If anyone doesn't have, if no one has any more questions, so we had someone just join us like 2 or 3 minutes ago. So they are getting a very short presentation, but that's what happens when you're a bit late. But yeah, audience, this is your chance. After this, you have to communicate with them via GitHub.
Or join the OWASP Slack. You're always welcome there, of course.
Well, and emails as well. Oh, I guess I could turn my camera back on. Hi, I'm still here and I'm still in outer space. This was really great. Thank you both so much for coming on. I really appreciate it. This has been really fun. I feel like I learned a couple new things and I already thought I knew. And I'm doing a presentation about secrets. So I plan to put your project in as one of my resource slides. So thank you.
That's really awesome, man. Thanks for having us as well.
My pleasure. If anything, I'm probably going to ask you like exactly what would you like me to have in the slide so that I can make sure that it looks like absolute best. This is so fun. Oh, Shlomo says he's in the OWASP Slack too. I'm there, but I'm not signed in. I have too many Slacks. Okay, well, thank you. Do you have a wrap-up slide that you want to do or anything like that? Or are we like pretty good? Can you put the, can we see the screen? There we go. So everyone take a screenshot of this because this is how you reach them and that's important. This recording is going to come out probably in 2 weeks from now because we released one today. We're releasing one next Friday, so it'll be the Friday after that. So we don't steal the thunder of the other streamers. But yeah, thank you so much everyone for coming and thank you two so much for presenting. This is amazing.
Thanks a lot for having us again.
Thank you.
And thanks for attending.
Absolutely. Okay, well, I'm really bad at saying goodbye, so I'm going to say yes. It was a great presentation, wasn't it, Jeff? Thank you.